All right, ladies and gentlemen, today we will all be able to recognize how a change in the value of b of slope-intercept form affects the graph of the equation. So we're going to just change the what's known as the y-intercept. First, we need to look at what slope-intercept form is. It is the form that we often see an equation written, and it makes it easiest to graph on a coordinate plane. It's written as y equals mx plus b. Today's main focus is on that value of b and how that affects the graph. First, we're going to change our equation to y equals 1x plus 0. Now, if you notice, we are simply changing that value of b to 0. The m is staying at 1, which is our slope, and we will graph each of these equations. So if we make x equal to 0, when we plug that value in, 1 times 0 equals 0, and then we would add 0 to that, and we get a y value of 0. And we put it over here in our little table. Next, I'm going to see what happens when x value is 1. I put in a 1, and I'm going to solve this same thing. And notice when we plugged 1 into our formula, 1 times 1 is 1, and when we add the 0, our y value would equal 1. So we go ahead and we add that 1 into our y value chart, and we'll move on to 2. And now I changed the equation up, and the x value is 2. When we put this in, our y value is also 2. So we're going to go ahead and put when x is 2, y is also 2. And then we graph these points. So we will very quickly graph them on our little graph that we have here. 0, 0, our origin, 1, 1, and 2, 2. And then all we have to do now is to connect those points with a straight line. And with this straight line, since it's yellow, I'm just going to make that straight line a yellow color. Okay, and we'll connect those and then add our arrows to the end of that straight line. So we add our little arrows to know that it goes on in both directions forever and ever. Now we're going to speed it up through our next line graphs a little bit, but you get the gist of it. We're replacing the value of x with one of these numbers over here, and then we're solving to figure out the value of y. And we use these as ordered pairs to plot on the graph. What happens whenever our b value is now 3? Well, if we solve this one, when x is 0, 0 plus 3, y would equal 3. When x is 1, y would equal 4. When x is 2, y equals 5. And so on. You can see the pattern. When x is 3, y equals 6. So I'm going to go ahead and graph those values. 0, 3, when I graph it over here, would be located at this point right here. And next I have 1, 4, which would be right here, and 2, 5, and it kind of keeps moving up. So now I'm going to connect them with a straight line in that same color. I'm going to start up here, connect those, and then we just add our little arrows to the end of this line. And we notice what happens. It looks like the same line, it just moved up a little bit. We're going to move on to the next one. See what happens again here. Now we have 1x plus 7. So if x is 0, y equals, and I better change my color here. If x is 0, y is equal to 7. When x is 1, 1 times 1 is 1, plus 7 is 8. When x is 2, y is 9. When x is 3, y is 10. And we can go ahead and graph that line. And you can see our graph of that line. When we went through our different points, we simply went 0, 7, which was right here. Then we went to 1, 8 up here. And then they started to kind of fall off the graph. But we can see that line again. Now we're going to move on and check out the next one. What happens when we subtract the b value? So here we have minus 3. Well, we'll fill out that chart again. And as we go about this process, when x is equal to 0, y is equal to a negative 3. When x equals 1, y actually equals negative 2. When x equals 2, y equals negative 1. And when x equals 3, y actually equals 0 here. So I'm going to go ahead and graph those. 0, negative 3 is going to be right in here. 1, negative 2 right here. 3, negative 1, 2, 3. Excuse me, 2, negative 1 is going to be right here. And then 3 right here. And now I can apply my line to this one. And we will just use similar to that color that we were using with this line. Let's go with, pink. And there we have it. Our pink line now. Moving on to the next one. So what happens now whenever we subtract 5 when our b value is minus 5? Well, let's go ahead and solve this one. And when x is 0, y would actually be a negative 5. And when x is 1, 1 minus 5 is actually a negative 4. When x is 2, we would have negative 3. And when x is 3, we would have negative 2 for y. So we can go ahead and graph these. 0, negative 5, 3, 4, 5 right here. And then we have x is 1 and y is negative 4 right here. When x is 2, y is negative 3. When x is 4, then y is a negative... Oh, I didn't even do that one. When x is 3, y is a negative 2 right here. But we can connect them then with a line again, just like we have on all the previous problems. So I'm going to put a line that goes straight up here, and then fix that line and add my little arrows to the end of it right here. Arrow, arrow. Alright. So you can see we did whenever we add 0, when the b value was plus 3, plus 7, minus 3, and minus 5. And this is what our graph looks like. Now, to get back to the actual question, as the value of b changes, what happens to the graph? See if you can answer that question in a few short sentences to explain how that value of b actually affects this graph. Okay, well, I hope that helped you out with understanding the effects of the value of b, or the y-intercept, in slope-intercept form on the graph. See ya!